So we're talking about classifying triangles today, and your learning target is I can classify triangles using their angles and side lengths. I can also use those classifications to find angle measures and side lengths. Okay, so let's get going here on a little bit of what this is all about. So there's two ways to classify triangles, and the first way is by classifying through their angle measures. The second way is through their side lengths. So there's 4 different classifications of triangles based on angle measures, and the first one is an acute triangle. An acute triangle just has 3 acute angles, okay? And what we're looking at is a shape kind of like this, where every single angle in here is an acute angle. It's less than 90 degrees. There's an equiangular triangle, and those have 3 congruent acute angles. Okay, so that means each angle is acute, but this one is more specific as far as saying all of those angles are the same. They're all congruent. The third one is a right triangle, and a right triangle has 1 right angle. 1 right angle. We can see there's 1 right angle. That's an easy one. An obtuse angle has 1 obtuse angle. Just like this one over here. And we can see this is the angle right through here that is over 90 degrees. So an obtuse triangle has just 1 angle, and that angle is over 90 degrees. Now, like I said earlier, there's 3 ways to classify a triangle by their side lengths. And the first one is by an equilateral triangle. An equilateral triangle has 3 congruent sides. 3 congruent sides, and those are marked by those little hash marks on each one of those. An isosceles triangle has at least 2 congruent sides. So it doesn't. That third side isn't congruent, but 2 of the sides are, kind of like this one here. It could be any one of those sides, but at least 2 of those sides have to be congruent in order to be in an isosceles triangle. And the last thing is a scalene triangle, and those have no congruent sides. No congruent sides, just like this one right down there. Alright, let's do an example. Example 1 says we need to classify each triangle by its angle measures. Okay, so the first one we're looking at is triangle BDC. That's this triangle formed right through here. And we need to classify that based on those angle measures. So remember, there's 4 classifications for angle measures. It's an acute triangle, equiangular triangle, right triangle, or an obtuse triangle. And we see here that triangle BDC has 1 obtuse angle. That would be this one that's 100 degrees. And it has 2 acute angles. This one's 10, and this one is 70 degrees. I only know that because of triangle proofs. Okay, so triangle BDC then has to be an obtuse triangle. It has to be an obtuse triangle just based on the fact that there is 1 obtuse angle. All right. Triangle AB, the second one here, triangle ABD. I want you guys to try that one on your own. Just know that the angle D right here in here is 20 degrees. Angle B and A are both 80 degrees. All right, let's go on to example 2. All right, example 2 says to classify each triangle by its side lengths, okay? And the first one we're taking a look at is triangle EHF. That would be EHF. And we can see here that there is 1 little hash mark here that describes some angle or some side is the same as some other side, and we can see HF is going to be the same as EF. So we see here that we have 2 congruent sides, 1 that is not. And if we go back to our triangle classifications by side lengths, we'll see that a triangle that has at least 2 congruent sides is called an isosceles triangle. An isosceles is difficult to spell. It's ISOSCELES. So that one is an isosceles triangle. Now the next one is triangle EHG. So that's this whole thing. Okay. Remember, this is 12. This one would be 14 then if we combine the 2, and this one's 11. I want you on your own decide if that's an equilateral, isosceles, or scalene triangle just based on the angle side measures. All right. Example 3. It says find the side lengths of the triangle. Okay, and we know here by looking at this triangle we have certain measurements. And we know that JK, the line JK, is equal to the line KL because of these little hash marks that are made here. So we need to find the side lengths of each triangle. So what that means we have to do then is we have to solve for x. And because I know that line JK, just kidding, is equal to line KL, I can go ahead and set those two equal to each other and solve for x. So we have 4x minus 10.7 is equal to 2x plus 6.3. And we're going to go ahead and solve for the x's. I'm going to get those on the same side, so I'm going to subtract 2x to both sides. We end up getting 2x minus 10.7 equals 6.3 is the only thing left after those cancel out. Then get rid of this 10.7. We have to add 10.7 to both sides. We end up getting 2x is equal to 3 plus 7 is 0. Add the 1. 6 plus 1 is 17.0. Okay, so I'm going to rewrite this now up over here because I'm running out of room. We have 2x equals 17. I have to divide by 2 on both sides to get x by itself, and I end up seeing x is equal to, 2 goes into 17, 8.5 or 8.5 times. Okay? Alright, so now that we know what the value of x is, we can actually go back through and actually solve each of those line segments for their value of x. And so I'm going to go ahead and just make a little key here. JK, just kidding, KL and JL over here. We're going to put each side length, and we don't know the units, so we don't have to put the units, but it's a good idea always to put the units anytime that you're not given them. Okay, so this first one, line JK, is 4x, and x is 8.5, remember? This is for line JK. Minus 10.7. Now this gets a little bit difficult to do just because sometimes when you're working with decimals it gets a little confusing. So I'm going to go ahead and say hi to my friend here. And we have 4 times 8.5, so 4 times 8.5 is 34. And then we have to subtract 10.7 from that. So we're going to subtract 10.7. We end up seeing it is 23.3 is our final units there. And if JK is 23.3, then KL should also be 23.3 because they are congruent sides. And we can check that out real quick. We could go 2 times 8.5, and then it asks us to add 6.3, so plus 6.3, and then it's 23.3. That's right. So we say, thank you, friend. That is right, 23.3. And our last one is JL. Line JL is equal to 5x plus 2. That means we have to plug in 8.5 to x. 5 times 8.5 plus 2. Again, I'm going to get my friend here, say, what's 5 times 8.5? We get 42.5, and we have to add 2, so it's 44.5 is our final length of that line segment. And again, we're not given any, we're not given any units specifically, so we can just leave it as is. Alright, example 4 says to draw an example of each type of triangle or explain why it's not possible. Alright, so this first one is an isosceles right triangle. So let's go ahead and just, what does that really mean? What that means, isosceles means that we have 2 congruent sides. I have 2 congruent sides. And a right triangle means there is 1 right angle. So I'm going to go ahead and start off with that right angle there because that's a little bit easier to do. And I'm going to go ahead and use my little ruler thing here, my straight edge. I'm going to go ahead and do just a 1 inch just to keep it even. And I know that I need to then create my next line, the right angle part of it. And this line should also measure 1 inch in length. Okay, and I know that's going to be true because it says there's 2 congruent sides. So those we can mark as congruent. There's my right angle. And then I just have to connect the dots here between these 2 spots. then I've created my isosceles right triangle. So now I need to build my scalene equiangular triangle. And so let's go ahead and scalene. What that means is that there is no congruent sides. All those sides have different lengths. And equiangular means three sides, all three sides are congruent. Okay, and if I have a triangle with all three sides congruent, that means since the triangle's angle sums add up to 180, all three of those sides have to be 60 degrees, right? So I'm going to go ahead and I'm going to just draw this out here. Alright, so I have all three of these angles are congruent, right? And what we'll notice is if we go ahead and measure the distance of all three of these triangles, we're going to get that all of them are the same size in length. They're all the same length. And the reason why, so what I'm saying here is that a scalene equiangular triangle is not possible. And the reason for that is because once you have all three of these angles being the same, those sides have to be congruent as well. Okay, so this is, oh snap, not possible. All sides must be congruent. So that's something cool that you guys know then about a equiangular triangle, is that if all three sides are congruent, then all those sides must be congruent too. Alright, have a wonderful rest of your day.